if it's really long,
Just do it. Yeah, verbatim. You can stop me if you want to. That's what I would do.
I'll trust you will do it in like 5 seconds.
Copy paste so it's done.
I got it. I'll just do it. Soda, but I have no
So the abstract, can you do you have the PowerPoint open by any chance?
Yes, very so simple.
Because I think we gotta find it.
Abstract's a little bit different.
I know. Yeah. Wait a minute. So should we say? What we use we ads, right? Jonathan, you're allowed to use we in the abstract, right?
I think we are because we are a team.
Where do you put the team? Because I just remember you weren't allowed to put the N except for the abstract.
Team.
From Chocolate, right?
Chocolate doesn't like we either.
But were we allowed to do it in the abstract?
I don't know. Joe would end up putting we in places anyway, because he thought we could. So I'm not sure if we're actually allowed to do that. I try to stray away from
I don't use it at all when I'm writing any technical papers. That's just a personal thing. But then again, no one's ever ditched it because I don't ever do it. So.
I just remember someone saying it was also in the abstract.
Just ask him right there.
I'll ask. It's fine.
When in doubt, just we just usually say
Okay, so
Sorry. Yeah.
Wait, that's better. That's
wait,
better.
are you still here?
There we go. I helped.
Okay.
I see cozy.
Police report.
But then it just closes it.
Anyways, so our
Kind of a
introduction.
bad view angle.
No, I can see it perfectly.
The introduction should be.
That's what we do.
Yeah.
There's a competition.
It's so easy when you do everything.
There's a competition.
Wait, what did you do?
I changed it to number of divisions rather than element size.
Okay.
Because like I asked you guys to make it like 50 elements on both the circuits. So that's how you do it. Number of divisions.
That's under edge sizing?
Yeah. The same parameters for the sizing. You
Okay.
can change it. Usually it will be the edge size, the default one, but you have to change it to the number of divisions.
Business model.
And then for the mapping, I select this face.
Okay, so you do that.
And say apply.
Yeah, I just stopped going. Give me something for sure. I was gonna fail. So I was like all sad. That's kind of what we. I was like, why? That's good. That's how there's no chance at all. Funny. But then I was like, oh, wait, there was like a lot of chance. Because I just thought the fine was like the 9%.
All right. So I'm doing the fluent one. So choose the double precision. Check the mesh just in case. In the models, use the energy model, energy equation. For the materials, you have to add copper. So go to the Fluent database for the solids, there is copper already there. So copy the material, but you have to change it, the thermal conductivity to 50. So 50, change, close. Then you can see copper and aluminum both coming in here. And then you have to go to the cell conditions. You have to have two materials in here, a solid and fluid separately showing here. If you did not define them as two different materials in your design itself, it will just show up as like one single material here. So you have to do that on the design side before even doing the machine. So for the solid, we have an internal heat generation which we define here. So edit this thing and make sure you select copper, not aluminum. And then if you click on the source term, the tab for the source term, it gets activated. Here, edit, create one source term at a constant value of 5000 watt per meter cube. For the channel, the default material is already air and we don't have to modify anything. So just leave it like that. The boundary conditions, the only boundary conditions you have to give is inlet, which is 0.05 meters per second at a temperature of 298 Kelvin. And the exterior, where you are defining the convection, 10 watt per meter square Kelvin, free stream temperature of 298. You should not define the heat generation here. This is the boundary heat generation. This is not what we want. Everything else is automatically taken care of. You don't have to change anything. The default values are already in there. And then the next thing is looking at the monitors, changing the residuals to 10 power negative 6. The energy one is already at 10 power negative 6, so you don't need to worry about that. Initialize the solution, standard initialization from the inlet. You can see the inlet values. Initialize. Run the calculation. You can use like 200 iterations. It usually is done within 160 or 170 something. Calculate.
Well, it's only been 7 years.
It's not to the two.
That's what it's like.
Oh, no, that's fine. It's not supposed to be that close, but.
You want to make it state of the art.
I'll just wait until for 10 power negative 3, not 10 power negative 6, and stop the calculation. But you have to make sure that the solution is converged. All these lines will go below 10 power negative 6, and that's where the solution stops. So basically what the software is doing is, it's trying to calculate the conservation of mass, conservation of momentum in 3 different axes, and conservation of energy in every element, and make sure that the errors are falling below 10 power negative 6. So that's why it is doing multiple iterations for each calculation.
Just mention that you enforced their research wasn't done.
Say that?
I've just seen the iterations.
Yeah. One more thing, if it so happens that the solution is just continuing without like going down, if it is like becoming like a flat line, something is wrong and you have to stop it there, or else like it will never converge. But right now you can see the numbers going down, so just let it continue. Alright, I'll just stop here. So I'm assuming the solution has converged. The next steps you have to do is look at your solution using your graphics and animation. So, but remember, it only gives you good pictures, but it doesn't give you any qualitative results. So if you just want to see like how the profiles look like, set up your contours, and if you are interested in the temperature profiles, select temperature. You can use the filled in option and select like which objects you want to select. The first tab, it selects all of them, and the second one, it unselects all of them. So if I'm just interested only in the channel or only in the solid, like I can select only the channel and ask it to display. It will select, show only the profiles on the display. there is one way you can maximize this view here. If you go to the view and ask it to unselect the embed graphics window here, then it will create in a bigger one. So you can maximize this and take a good screenshot of it. So if I select all of them and ask it to display, this is what the temperature looks like. Essentially what it is telling us is like this whole cylinder is pretty much at like the same temperature. It's almost like behaving like a lump system. Okay, so but in the example I gave you guys, like I showed like only one plane where the temperature profiles are defined. The middle plane, if you want to get like a picture like that, you have to create that particular plane, a middle plane. Right now we don't have that middle plane. I can create the middle plane using the new surface function here. So creating a plane, a new plane. Remember, a plane has to be defined with 3 points. So I'm defining 3 points, 0, 0, 0, 0, 0, 1, 0, 0, and 1, 0, and 10. So basically this is defining one of the middle planes I can get. I'm just calling it as a mid plane, ask it to create. So unselect all of them and just select the mid plane and ask it to display. You can see the temperature profiles coming only on the mid plane. And also in my example, I have the whole cylinder as like an outline coming on that. You can create that also in your Fluent here. So in order to do that, you just select the draw mesh, and when you got the meshing window here, select the outline and select only the exterior. Basically I'm selecting all of them and unselecting the ones I don't want in here. So I'll just select and select the main big ones and ask it to display once. It will show you how it is going to look like. You can modify it if you want, but then if I am satisfied with this, I'll say close and then go back to the original contour window and ask it to display by keeping this one checked in. So if you ask it, it will show the cylinder as well as the temperature profiles you want. I mean, these things are like good for taking like a good snapshot of it. And similarly, you can also draw the velocity vectors. So I'm just drawing the velocity vectors in the channel. That's all I have anyway. There are too many velocity vectors in here. There is a way we can modify that. You can skip some of the vectors, say skip 10 of them. And then it will be slightly better, but you can skip more also if you want. Say I'm skipping 50 of them, and I can also scale these images. And in scaling them, I have to make sure that the vector go to the vector options, ask it to make it to a fixed length, and you can play with the scale head if you want. I'm just choosing like a random number of 0.3, apply, and come back here. And if I just leave it like as a 1 and ask it to display, this is what is going to happen. Two big vectors coming in there. So you can just like reduce the size by scaling it to say 0.25. Maybe they are still big. Yeah. So 0.05. So this is slightly better, but you can maximize these things like this one here. Embed the graphics window. So anyway, so you can play with the vectors options also. But the last thing, which is like where you collect the data, this is what the plots do. So you can select the plot in the XY plot, set it up, and I want to measure the temperature profiles at different radii. So choose the temperature, and remember you are trying to measure in the axial direction, which is in the Z direction in this particular geometry. So your Z has to be 1. And then I want to the temperature profiles at different radii. That means like different lines along the axis. I have to create that particular lines. I'm creating the lines using a line command here. So starting from at a radius of 0.25, y point is 0 and 0, a radius of 0.25, y point is 0, and length of 10. I'm just calling it as line 25. Create. Similarly, you can do for 375 also. ln 375 and 5. So all of them just like do it like one after the other. Line 5. Create. So once you created 3 lines here, just look at the plot. You can see the temperature profiles going in. But right now you're not seeing any values there. It's just like a plot. You can put the plot as it is, but if you want the values, a better way of doing it is write to a file and ask it to order the points. Writing the file, it is just like write down an XY file. Just give some name, so LMS, okay, and come to your desktop. Use Microsoft Excel to open this thing. Computer, desktop, all files, lines, open, delimited with a space, next, finish. Then what you can see here is the coordinate towards the z direction from 0 to 10 as it is increasing, and right next to that the temperature values. They are already ordered there. The first one is at 0.25. Oh, come on. Dual monitors. Anyway, so you just have all the 3 lines data which is already in your Excel file. So you can just like modify this data, put it into correct format, and make your own graphs also. I strongly recommend against using the Fluent graphs. They don't give any information. They have unnecessary big squares coming in there. Like for example, that line is too thick and it's not like almost like they're too close. It's not giving any information. One more thing you can do is you plot these 3 lines using Excel or MATLAB or something between 0 and 10. But most of the important information is in the beginning, so try to draw from 0 to 1 in a separate plot. Right next to that, just like show how these temperatures are increasing between 0 to 1 also, because that's where most of the action is. After that, it's like pretty much flattening out. Alright? So do the same thing for different radii also. Not radii, but different. What else I asked besides this thing? Is it the only temperature profile I asked?
3 different radii.
That's what we just did.
It's like 0.5, 40 seconds. You got the one thing where
Yeah.
it's set, and the other thing said something about 0.25, 0.375, and 0.5, and here it says 0.5.
But yeah, that's like a typo. It should read like the same radii which has like on the top.
Okay, so you want the ones that you entered, the 0.25?
Yeah.
equals 3 cents?
So there is one more thing. Like right now, this graph what is giving is not a normalized one. So you have to extract the data onto the Excel file to normalize the data. Okay. So how do you normalize this thing? Like, so if I have like a data like this one, I can normalize this one using B5/298. I'm just normalizing with respect to a free stream temperature of 298. So I can go like that. Okay?
Could you go
So all of
over that
them
one more
are
time?
just like right above like 1. That's what you have to do in the normalization. Right?
One more time, could you repeat the process, the normalizing?
Oh, like I mean, once you get into the Excel file,
Yes?
right next to the temperature values, divide each temperature value with 298,
Oh,
so that which is the free stream temperature.
oh,
And then you get like a normalized value just right above the 1.
and then we graph the normalized one.
Yeah.
Oh.
Okay. Is it clear for everyone?
Yes.
Right.
How